All right, for today's midterm review questions, we're going to be looking at some of the concepts belonging to chapter 5, work, energy, and power. And question 16 here reads, the total energy input, E sub n, in a process is partly transferred to useful energy output, U, and partly transferred to energy that is wasted, W. Doesn't transferred have two R's in it? Anyway, this is an English class. What is the efficiency of the process? You may recall that efficiency is the useful power out over the total power in. Power is energy per time. So an equivalent way to think about efficiency is a ratio of energies, useful energy out over total energy in. So we really just have U divided by the energy in. That's sort of the way we define efficiency. And then if we want it to be a percentage, multiply it by 100%. And so that agrees with choice A. We could relate sort of the total energy in to the useful energy out by saying, well, whatever energy we put in, some of it is wasted. So we could subtract away the wasted energy, and that's how we would get like the numerator here. But we can just sort of look at choice A and realize, well, that's the definition of efficiency. We don't really need to consider how to calculate U, but just for completion's sake, we go over that too. Sometimes you'll see efficiency questions in terms of the wasted sort of heat, right? And so that's why it's never 100%, because there's always some energy losses. We never get 100% useful energy out to what we put in, right? There's always something less than 100%. Another good sort of review item for this is to be mindful of, if you ever do a calculation of efficiency and you get an answer that's more than 100%, you probably confuse the numerator and denominator, right? You say it always has to be less than 100%. Right? Nothing is 100% efficient. Theoretically, it could be, but it certainly can be more than that. If it is, and you discover a process that's more than 100% efficient, keep it a secret, but tell me about it, and then we'll sort of make a machine, a perpetual motion machine. We'll put in 1 joule of energy. We'll get like 2 joules out, and we'll sell that extra joule. Okay, and that's sort of why it's impossible. You can never get more energy out than you put in. There is an abundance of energy in the universe, though. So if you're just sort of smart about how you harness the sort of abundant available energy, you could sell that. All right, moving right along here. We have a gas is enclosed inside a cylinder, which is fitted with a frictionless piston. Initially, the gas has a volume V1 and is in equilibrium with the external pressure P. The gas is then heated slowly so that it expands at a constant pressure, pushing the piston back until the volume of the gas has increased to V2. How much work is done by the gas during this expansion? So one of the equations that we went over for work, energy, power is work that's done on or by a gas. And if you look through your notes, you might be able to find that the equation for that is work equals pressure times the change in volume. So you're looking for sort of which answer choice agrees with that. They're defining the pressure as P. The change in volume, any change is always final minus initial. And so if you look at choice A, then you can see that that agrees with that, right? V2 minus V1 would be the change in volume times the pressure P. And so choice A is correct here. For those students that are preparing for an ACE exam for paper 1 towards the end of the year, or even paper 2, remember that you get a list of formula here. And indeed, the second, or I guess it's the third equation, they give you 2 of the equations for uniformly accelerated motion. These are 2 of the big 4. And then they have work done on or by a gas. And there it is right there. Work equals pressure times delta V. Now they don't define those variables for you. So you have to know like this P is pressure, right? And this delta V is change in volume, because V has also stood for velocity. Like this V here is velocity, right? And P could be power, pressure. So work is pressure times the change in volume. Ooh. Firework problem. Nice. And so for question number 17, the correct answer would be A, and that's just sort of realizing that the change in volume is the final minus the initial. These have been 2 worked examples with Dr. Schleich, and we'll see you next time.